Alright, so guys, today we went around the street and we collected some data from some random people. We went around and we wanted to find out what their shoe size was, and then we measured their height without their shoes on, and we measured it in inches. So we got a total of 8 random people on the street. First one said their shoe size was 12, and we measured them, they were 77 inches tall. Now that comes out to 6'5", so they were pretty tall. Next person we measured, their shoe size was 10, and their height was 71 inches. Then we had someone that was a shoe size of 7 and then 63 inches tall. Someone that had a 6.5 shoe size, they were 64 inches tall. And then we had an 8, 65 inches tall, a 10, 68 inches tall, 9.5 shoe size, 67 inches tall, and a 12 size shoe again, but this time they were 73 inches tall. So once we got all this data, we put it into a table, as we have here. So now that we have that data, let's answer a couple questions. What equation represents the line of best fit for this data? So if we're going to make predictions, let's have an equation that we can plug our data into. Okay? Then also we want to answer, if Oscar, the grouch right here, says he wears a size 4.5, how tall can you predict he is? So can we accurately predict how tall Oscar the grouch is, just based off of his shoe size? Then once we get that, according to the data we were given here, how accurate is this prediction that we're going to make? And then is it going to be a strong or a weak correlation? And will it be a positive or negative correlation? So those are the things we're going to be looking at today. So first of all, what equation represents the line of best fit for this data? So we have this table here. And if you remember in one of my videos before, I had shown you how to use the TI Nspire calculator to use List and Spreadsheet. Okay, so we're going to go ahead and use List and Spreadsheet over here. I'm going to pick up my calculator, go to List and Spreadsheet, and plug in that data. Now, I've already plugged it in to save us a little bit of time, so I'm going to go over here to Current, which will open up my current tab that I was just working on. And here it is. Now, instead of X and Y, I labeled it as my shoe, because my shoe sizes are here, and my height, because we measured their height in inches here. Now, again, we could have put X and Y. That's totally fine. And just to show I had all 8 people's shoe sizes put in and their height, okay, have all 8, so I have all my data plugged in. Now, once I have that, I want to know what the linear regression line is, or the line of best fit, which is also called our trend line. So I go to Menu 4.1 Read, 4.1, and then Read, there's linear regression right here, mx plus b. So I click on that one. X list in my drop down. Well, my X list was my shoe size, and my Y list was my height. Okay, it saves it to F1 in the graph app, which is where I'm going to go and get my line of best fit, or my equation. So I go to the home screen, down to the graph app over here. It is saved as F1, the first function. So I go up, there's my equation. I push enter to graph it. Now, I can't see it at all. Well, I don't know about you guys, but I feel like spiders find you no matter where you hide. And so let's pull up our spider. So our menu 5.1, trace and then graph trace. There it is, the spider found the graph for us, found our line. All right, now, here's our equation, right? And so I'm going to go ahead and write this down as our equation. So 2.17x plus 48.1. So we're going to go ahead and take that and bring it on back and write it down. So we had y equals 2.17x plus 48.1. Let's double check, make sure we wrote it down correctly. So y equals 2.17x plus 48.1. 2.17x plus 48.1. We've got it. So there's our equation. Now what was the next thing that we were trying to find? Well, if Oscar says he wears a size 4.5, how tall can you predict he is? So we need to make a prediction here, right? We need to figure out how tall is he if he wears a shoe size of 4.5. Now we don't have any shoe sizes here that are that small. Now we can assume it's going to be smaller than all these heights, right? So let's go check it out. So a size 4.5. Now, in our other video, when we said we were trying to find predictions, we said we could open up the table. So I'm going to go Control-T as our shortcut to get to the table. Here we go. And 4.5 is in between 4 and 5, so it's going to be between 56 inches and 58 inches tall. All right, now I'm going to go into the settings. So Menu, Table, and then edit table settings. And I want to go by half steps because we want to find out that 4.5. So 0.5, and I want to start at 4. Now I could put 4.5 if I wanted, it would go straight there, right? But I want to go ahead and just see it this way. So at the size 4.5, he'll be around 57.9 inches. Okay, so let's go and write that down. So he'll be around 57.9 inches. And then how tall is that? So let's go check it out in feet. So let's go make some conversions real quick. We go to our calculator app. We had 57.9 inches. Divide that by 12 because there's 12 inches per foot. So he's 4 feet and 0.825 of a foot. So let's try to turn that into inches. So 0.825 of a foot, we multiply that times 12 inches, and we get 9.9 inches. So he's approximately 4'10". Would that make sense? Oscar the Grouch being approximately 4'10" tall? Well, I mean, he does fit into a trash can, so maybe, right? So our prediction says he's about 4 feet 10 inches in height. Well, I would assume that seems correct. I mean, it seems legitimate, but again, we only questioned 8 people in the street, so that's not a whole lot of data. Now, if we had hundreds of people telling us their shoe size and their height in inches, then we might get a more accurate prediction. Now, according to the data we were given, how accurate is our prediction? Well, let's check it out. Let's see how accurate it is based off of these numbers. So we go back and look at our calculator. We go back to List and Spreadsheet, and again, to find out how accurate something is, we want to find out what is the correlation coefficient. Okay, so that would be our letter R right here. So it's 0.935, and that translates to 93. Oops, I put that decimal a little too early. It translates to 93.5%. Okay, so it's 93.5% accurate. That's really accurate because if it's over 80%, then it's going to be a strong correlation. Okay, not a weak correlation, it's strong. Now, is this a positive or negative percent? That's easy to find out. It's a positive percent. Otherwise, it would have a negative sign in front of it. So we would call this a strong positive correlation. All right, so according to the people we found on the street, we can assume that Oscar the Grouch, with a shoe size of 4.5, he's approximately 4 feet 10 inches tall. All right, so hope you enjoyed figuring out how to find out height based on predictions using List and Spreadsheet app. Now, there is one more thing I haven't shown y'all yet. It's another little shortcut inside the List and Spreadsheet app, and then whenever you go over to the graph. Now, you don't have to be using List and Spreadsheet to do this, but if you're in the graph app, right over here is where I was, and let's say I didn't want to use the table. Let's say I was just using the spider. Okay, so let me get rid of my table, Control T, and let's say I was using the spider, menu 5.1, graph trace, because I'm tracing the line with the spider. Let's say that I was going for a very large number for X, and I didn't understand or remember how to get into my table settings or into the settings to change where I'm located, okay, to find my prediction. What I could do is if I know what X value I'm looking for, so for like Oscar the Grouch, I was looking for X when it was equal to 4.5. I can type in 4.5, and if you look on the screen, now it says X equals 4.5. I didn't put X equals, I just put 4.5, right? And so what that's going to do is now whenever I push enter, it's going to jump the spider to when X equals 4.5, and I look to the side, it gives me the Y value prediction. So let's say we're looking for a large number, maybe not shoe size, because I don't know anyone with the size shoe of 1500 or 1500, but let's say we were looking for when X equals 1500, we could just type it in because that's what X equals 1500, and I want to see where that's at, what does Y equal. So I push enter, and then it jumps me all the way up there to when X equals 1500, and it tells me that it's 3.31 times 10 to the third, okay, so that'd be 3,310. All right, so just another shortcut, little Easter egg in the graph app. I hope you guys enjoyed that, and come back for the next video to find out more.